legacy of meteorology in India can be traced back to 3000 BC era onwards. Epic manuscripts such as the Upanishads, Varaha-Mihira's Brihat Samhita, Kanad's Kanad Sutra, Kalidasa's Meghdoot, and Kautilya's Arthashastra bear testimony to the deep knowledge of atmospheric processes in India since ancient times. In post-independence India, IITM, under the aegis of the Ministry of Earth Sciences of the Government of India, has carried forward this rich legacy by venturing into new areas of research and service and by developing path-breaking methods and technologies. Continuing in its tradition of trailblazing innovations, IITM proudly presents the Made in India IITM HGFM High Resolution Global Forecasting Model, a quantum leap in weather forecasting.
In line with the Government of India's mission of Atmanirbhar Bharat, our Make in India initiative, the high resolution global model at 6 km resolution in the tropics developed by the scientists of IIT Pune will be a major step forward to improve our forecast capability, especially to capture extreme weather events, thunderstorm and other smaller scale events.
In the past few years, the number of small-scale weather extremes have risen exponentially. And since the prevalent GFS has an inherent limitation of horizontal resolution, a dire need was felt to have a forecast model capable of providing increased horizontal resolution to forecast extreme weather events much ahead in time. However, directly increasing the resolution poses computational and other challenges. Hence, to overcome these issues in the existing model, IITM scientists innovated an out-of-the-box solution and adopted TCO, the Triangular Cubic Octahedral Grid, and thus was born IITM's HGFM, the highest resolution global forecast model. The TCO grid provides horizontal resolution of near 6 kilometers in the tropics, which gives much finer resolution than the near 12 kilometers of the GFS.
The TCO grid is also being used in the IITM Earth System model for long-term climate studies, and we expect that with this feature, the use of the TCO grid in the IITM ESM to improve the simulation of the winds over the equatorial areas and over the equatorial oceans, and in turn improving the quality of the ocean currents in the Indian Ocean and the Pacific Ocean and the Atlantic Ocean.
The TCO grid uses cubic truncation, in which each wave is represented by 4 points instead of 2 points, as in the linear truncation of the GFS. There are various advantages of using a TCO grid over conventional reduced Gaussian grid.
With increase in resolution, the orography is better resolved. As a consequence, the variability in the wind pattern and the spatial rainfall are well captured.
This new model uses scale-aware convection scheme for shallow and deep convection that also takes care of the varying resolution from equator towards the pole.
This model represents atmosphere more realistically compared to the present grid. While existing 12-kilometer GFS model helps to generate block-level forecast, IITM's HGFM model will help to reach forecast in a spatial scale smaller than a block level.
This model has a resolution of around 6 kilometers at the equator, and the grid size varies while going towards the poles. The new HGFM model is being run on the present HPC system and is very scalable.
The IITM HGFM model is powered by a supercomputer and hence has a robust yet a very flexible structure.
The high-resolution global forecast model, the HGFM, uses a semi-implicit, semi-Lagrangian spectral transform method to compute its dynamics. It uses a cubic grid in the spectral domain and an octahedral reduced Gaussian grid in the physical domain, and simply known as TCO grid.
This path-breaking model is developed in a methodic and systematic manner. Firstly, a globe depicting planet Earth displaying only the oceans is generated. Secondly, all continents with their respective mountains and elevations are added to the globe. And then the vegetation is added. Finally, after working on significant mathematical calculations on a high-powered computer, a realistic Earth atmosphere high-resolution model is created.
The ministry had targeted to increase the horizontal elevation of the forecasting system from 12 kilometers to 6 kilometers. We are very happy to announce that the Dr. Parthasarathi Mukhopadhyay and his team at the Indian Institute of Tropical Meteorology, Pune, have successfully developed this new forecasting system with a horizontal elevation of 6 kilometers.
This new model is an attempt to indigenously develop a 6-kilometer global model. This model resolves the sub-grid scale process better, and the emphasis is to improve the sub-block level forecast with better fidelity.
This model is being run daily for the present monsoon season on an experimental basis, and the results and preliminary analysis are indeed very promising. After a thorough validation and performance evaluation, this revolutionary model will be handed over for operational implementation.
I would like to wholeheartedly congratulate the IITM scientists and the modeling teams for this outstanding contribution in weather prediction and also climate modeling. And I am fully confident that in the coming years they will keep innovating to reach newer heights and greater horizons.
Today, meteorology in India is poised at the threshold of an exciting future, and IITM's HGFM model will usher in a paradigm shift, and a new era in weather forecasting will begin, leading to substantial benefits that will aid the rapid progress towards prosperity for all in our glorious nation.